All right. Welcome everyone to today's episode. Was it definitely not counting months on my fingers, April 7th, 2022. Um, so first off, we have the 2.5 release coming out imminently. What do you say? Next couple days?
It's gonna be today, no matter what.
Oh, okay.
So while we were kind of playing a little game of, so there's a Go release, sort of ominously, that has a private, secure, and undisclosed CVE that is part of it, and that was supposed to come out today. So we were kind of keeping an eye on that, and then they just updated the mailing list to say that they're having trouble with their release tooling. So that's gonna be Tuesday. So we're not gonna wait for that anymore. So now, as I was joking earlier, I just need to get off of this call and a call or two after that, and then we'll circle back around and tag it. But it's ready. Release notes are ready and getting reviewed. The branch is ready, and everything that we wanted to backport is backported. So I copied the release notes in here. So if this won't publish probably before the release, so I think it's just those that are here. Uh, a lot of improvements for performance in this release, which is really exciting. So we've got a forked version of the um, Go standard lib regex library, which makes a number of improvements around how Loki uses regular expressions. Owen did this work here to make binary operations significantly faster by leveraging the query splitting and sharding for multiple parts of the binary operations. There's a new schema, so V12 schema. If you're running on, mostly probably will only be interesting to you if you're running on S3. S3 has rate limits that apply on a prefix, and the V11 and older schemas all put all of the chunks in one prefix, so you can run into rate limits, usually on reads if you're pulling in something like, I don't know, was it 5,500 requests a second, which you can actually do with a big enough Loki cell with enough parallelization. So the V12 schema breaks up the storage into more prefixes so that you can get more parallelism without getting rate limited. Um, that was also ported to the file system store, mainly because we've seen feedback, and I totally get it, where having all of the chunks in one directory is sort of non-optimal operator experience. If you have millions of files in a directory, Linux gets a little grumpy.
It is an accident that we did that. Right. So the V12 schema was very it's just an easy way to hook in to the ability to fix it moving forward.
Yep. So just took advantage of that. Hedging storage requests is pretty neat. I looked for the weirdo because the Tempo did this first, and I thought they had a blog post directly about it, but I can only find their release notes. But the idea is you make a request to pull a chunk from the object store, which you might do thousands or tens of thousands of in a big query. Sometimes they're slow, and we basically, we do a lot in parallel, but at some point you always have to wait for some amount of ordered returns before you can continue. And you can see that, like, if most requests take 100 milliseconds, but one takes like 3 or 4 seconds, that 3 or 4 seconds often dominates the query performance. So what hedging does is you largely configure it around what your kind of P99 normally is, say like 500 milliseconds or 200 milliseconds, or like what your sort of normal request, maybe like more like a P50. And if a request takes longer than that value or that time, it'll send another one, with the theory that that one will likely return quicker. And so then whichever returns quicker gets the result. So it basically gives the Loki a chance to say, hey, sometimes things are just slow for whatever reason, so just try it again real quick. And that can help a lot on queries that do a lot of fetching and parallelism. Promtail get a bunch of new ways to ingest logs, including Docker daemon service discovery. So this was added in upstream Prometheus. You can use it a couple ways. You can actually use it the way we typically do file service discovery. So you can tell it to ask the Docker daemon what the name of the containers are and use that to construct paths to tail files. But it also has the ability to essentially query the logs from the Docker API. So there's a logs endpoint in the Docker API, so you can do it that way as well. I believe the PR mostly focuses on that approach. Then you don't have to play around with access to the file system. And then there's ways to pull in logs from Cloudflare, as well as the Graylog extended log format. You can set up I can't remember, I think it's a UDP listener to receive, maybe it's both TCP and UDP, but receive logs in that format and ingest them. And then last things from Promtail are the ability to do rate limiting on the client side. So if you wanted to limit how much one individual Promtail can send, I know lots of folks have environments where you're sort of operating infrastructure on behalf of other people, and you can't always get them to do what they want. And depending on how the multi-tenancy setup is in Loki, this is a way to prevent a user of a shared tenant infrastructure from overwhelming the limits that might be applied on the server side. So this gives a couple more options there for people operating and running Loki infrastructure. That's it. Yeah. 2.5. Anybody have any questions? A bunch of fixes in there too, like a whole lot of fixes. I strongly recommend upgrading. Oh, if you upgrade, like probably 99% of you are going to find that we made one change that is a bit intrusive, which is there's a configuration called split queries by interval, and it was previously could be defined in two places, in the query range config block and in the limits config block. In Loki 2.5, Loki will fail to start if it's defined in the query range config block. So we kind of went back and forth on how to do this. We went with the kind of pull off the Band-Aid approach. And basically you need to define it only in the limits config section. So what we did is update Loki to read from the limits config section for this value. There'll be, and this is in the upgrade guide, you don't have to remember this, but if you start it and it's in the spot, it actually just spits out an error message and it tells you what you need to do. Aside from that, there are no other changes that should be sort of, noticeable or stop, invasive, I guess. But we did change a lot of defaults around how parallelism between 2.4 and 2.5, we've really pushed the direction of making parallelism by default, even in the single binary modes. So any queries that you run will get broken up into pieces and parallel. So on a single binary, it's all within, threads on the same machine. So you probably will see increases in memory and CPU on queries specifically. The configs that we changed are in the upgrade guide too. So you can turn it off if you want to go back to single threaded querying. But I think our philosophy is most people probably want to take advantage of that parallelism. So
yeah, there's like a big trend here, right, of trying to get closer to more opinionated and saner defaults, and we learn a lot about what makes more sense the more that experience that we get building Loki and operating it. But I think a lot of these will be generally very helpful for people. Honestly, like the biggest one that I'm looking for here from this release, aside from all of just like the performance improvements, bug fixes, just like all these quality of life benefits, is the new schema that's coming out. Right, we've had this problem with AWS historically. AWS S3 had some nuances in how it operates, and that didn't play very nicely with our existing key structure that we use for chunks in S3. And so now the new key structure should largely allow these rate limits to not be a problem anymore. So if you are struggling with S3, if you're seeing rate limits coming out of there, definitely upgrade to the new V12 schema.
Anybody that's not done a schema upgrade before, you add a new entry. So the schema is a roll forward type setup. So anything that you've created to date would be addressed and found with the current schema, and you would add a new entry in the config with a new start date. That start date needs to be in the future. So you want it to be, say, tomorrow. And then it rolls over at GMT. It'll start reading the new schema and creating things with the new schema. And then we'll handle sort of querying back and forth between the old and new. Don't really have a way to migrate between schemas. you actually can. I have done this. There's a migrate tool in the Loki repo that I made. There's a big old warning at the top of it that says like, caveat emptor basically. So it does let you do this, but we don't really as a practice do it much. So
Don't tell people to do this, Ed, please.
it's you can do it. It's just maybe don't start with your most valuable data.
Actually, you know what? Do this. Make sure that you ping at Ed Welch on public Slack. He will make sure to take time to address any concerns.
So a bunch of folks joined after we started talking. So I'll go circle back around. 2.5 isn't actually, I haven't cut the tag yet. It's going to happen in probably another, I'll say 2 hours because I get a call after this too. So in a few hours time, there'll be release for images and tags for 2.5. We're gonna have a blog post about it tomorrow. So maybe tomorrow on, so I could do a nice Friday upgrade. Sounds like fun to me.
Yeah, I didn't even think about that. Good point. It's like it's very on brand for us, right?
We've done Friday releases before.
Exactly.
We did a Christmas Eve release one time.
Okay. Are you done? Are you done with the 2.5?
I think so. Unless anybody has any questions, we got quite a few folks join, so I'm happy to answer any questions, or we are happy. All right, Owen.
You can also ask questions at the end too. Totally fine.
Yeah.
So let's see. I did not do as good of a job with this description as Ed did. Notably missing a lot of links here. Is there an example of the new structure in S3? Yes. Can find one after. No, actually. Let's see.
You want me to look for something?
I'm trying to remember. Do we have this in docs or not?
There might not be an example in the docs just yet.
I think the long and short of it is that the stream fingerprint hash is now part of the prefix. So it used to be index / you would be tenant /
there we go.
tenant ID, or was it actually called tenant? Sorry, you feel like I should know this, but there was a high level folder. I think maybe chunks / tenant ID / all of the tenant ID chunks, and now it's going to be. Are you looking at it?
Yeah.
Okay.
But you got it.
Yeah, and then so the fingerprint. So we actually played around with a lot of versions of this and like having more, and we went with the approach of maybe taking it simpler to start. But basically, every stream now gets a folder within the tenant or the user in this case. It says folder.
Let me see if I can add this. Old key structure was. New key structure is.
it makes it seem like it was, really simple. There was a lot of work went into sort of playing around with and testing and benchmarking and trying to. So we're I don't remember what the number of reads per second. We did do some benchmarking on this. I don't know that
this is the big one. That's not what I wanted.
The PR.
Like highlighting. Good, nice orange. Yeah. So this is the difference here.
Deciding on this simpler approach too was great because we did some forward-looking thinking and experimenting as well. And as far as we could tell, this supports the vast majority of use cases for even large Loki deployments on using S3. But it was good for the Loki team as well to experiment and learn more. And we even have future ideas if we get to a scale where somehow we need to even support even better request parallelization to S3. So,
yep. The kind of big difference there being, even though it's a very small change, right? We just basically replaced a colon with a slash. S3's the way that S3 prefixes work turns out to make this much better for rate limiting purposes, and it hopefully we'll see this problem largely disappear for the users who have been having that problem. Okay. Yeah, so we've been in for, I don't know, maybe a year ago, we started kind of identifying some bottlenecks and kind of issues with the Loki storage layer, and had come up with a couple kind of internal designs for what we could do. And recently that materialized in a plan to write a new index for Loki, largely based on TSDB, which is part of the Prometheus project. And so that's what I've been kind of hacking on for the past, I guess, 2 months now or so. And it'll function very similarly to how BoltDB, the BoltDB shipper works, in that it lives in object storage alongside with your chunks. And so it'll be, again, operationally very much simpler compared to the old way of operating Loki, where you had a dedicated index store. But the benefits here being that it should be much, much faster and should require less resources to run. So we'll, particularly on some of our larger clusters, we can spend a fair amount of generally CPU time on the index queries themselves. And this should shave off a lot of this, meaning that we can kind of run Loki a little leaner, as well as run it, as well as have better performance numbers. So faster for cheaper, not bad. One of the other big changes here is that some of the data that we are storing in the index will allow us to make certain queries available based on the index alone, meaning that we don't have to pull chunks. Particularly, this is relevant for the series endpoint in Loki, which can basically, for a set of matchers, can give you all of the resulting series that satisfy that request. And this is used in things like Grafana autocomplete. So historically, the long tail on these the long tail latencies can be very high. And now we should be able to run these off of the index alone, and hoping I can share some more actual performance numbers when we get that far. But the expectation is that it'll be, it'll go from, maybe 1 minute P99s to fractions of a second. So, which is much more in line with the use case of that autocomplete style. Another thing that we're going to be getting out of this TSDB work, is the ability to do dynamic sharding. So one of the ways in which Loki makes queries fast is by parallelizing it across all of the labels of your series. And historically, a shard factor is coded into the index itself. Generally, this is 16 by default for the recent schemas. What this means is that in the sharding phase of our query planning, we will generally shard things out 16 times. Now, that is very helpful a lot of the time, but it's a cluster-wide control, which means that if you have a tenant with a very small amount of data, maybe it's suboptimal to shard at all. Maybe you don't even need to have that optimization. It might work well for some tenants, then some tenants might be large enough that 16x isn't really enough for some of the queries that they run. So the idea here being that we can move this from a cluster level problem to a request level problem, so that we can say, okay, Loki can process, for an average query, 400 megabytes a second. It can read that many logs. So what we actually want to do is we want to figure out how much data we are operating on, and then shard down till we get close to that number. And then by doing that at a request level, it accounts both for tenants which have different throughputs, different amounts of logs, and as well as queries which are more or less expensive than other queries. So that should really get us to a much more optimal position. And I'm hoping we can share some, when we get that far, some really nice performance benchmarks as well. The other thing is that this paves the way for a whole host of future optimizations, which I just talked about some of around query planning, but also things like features which can run off the index alone, meaning that they'll be very cheap to run because you don't have to pull a lot of logs from S3 or whatever your object storage is. And that'll be very attractive for things like label and cardinality analysis, which I think would be really great features in the future, as well as like downgrading our existing log volume histogram queries, which are a relatively new addition to Grafana, which will basically show you the distribution of logs for some query over a period of time. And often, or not often, but occasionally, the long tail again here is very problematic. So you can have a query that is maybe some filter query, which seems very reasonable. But if you try to run that over a week-long period, right, the metadata to get that, it can be many, many times more expensive than the query itself. So there's kind of a lot of things that we'll be able to do afterwards, and it should allow us to build new, richer features on top, which I'm very excited about.
When's it going to be ready, Owen?
Yeah. Hoping to have it running internally on some Grafana clusters end of month, but I need to close Slack a little bit and get some of that work done.
Yeah.
As for being released, I'd probably guess a couple months after that.
Yeah, probably more than that. But I think we might target maybe a fall Loki 3.0 kind of. I don't know. We'll kind of see how it all shapes up. We're in the earliest stages of this. We put a lot of thought into it, and the history of Loki's index is kind of interesting. We started by using a NoSQL store and requiring it separately, so you had to have Cassandra or Bigtable or DynamoDB, but there was always this BoltDB version that you could use in the local config. So then Sandeep, it's a bit late in the day for him to join, did a bunch of work with what we call BoltDB shipper that takes the BoltDB file and just uploads it to the object store, and that's how we largely run Loki today. We still use a NoSQL index. That's how we recommend everybody run Loki today. And we still have this NoSQL index, just we kind of move it around and put an object store ourselves. However, it's basically a key value store that we've used to store our data. And then you have what is the TSDB from Prometheus, that is a database built around the sort of label model and data that we store. So it's a highly tailored index for exactly what we do, except it stored postings offsets to blocks that go into the Prometheus TSDB format or something like that. Some of those words are right.
I'm just thinking, like, how valuable is that sentence to this call?
Anyway, we changed it to support looking at where our S3 objects are. But what it does really well, which is nice, is it interns all the label names in one place. So you get a huge size reduction when you have, so in our current index, there's some amount of deduplication or deamplification done on labels, but it's not nearly as effective as what the string interning can do in Prometheus TSDB. So indexes get a lot smaller. We should be able to support a lot more streams. And it can answer a lot of the queries like Owen was talking about much quicker about things like series and labels and values. And then we're going to punch a bunch of metadata in there to be able to help do more query planning and things. So very exciting. Quite a bit of work to go, but it is actually kind of real. I mean, it is, there's real code. It really works.
Yeah.
Not quite in a cluster yet, but very exciting.
Yeah, we are pretty happy with the kind of where TSDB is for us right now. We're using kind of a fork at the moment. Definitely looking at ways in which we can recontribute a lot of this stuff upstream. But for the moment, we're working off of a fork, and all of that's in Loki right now. It's just not wired up to the rest of the components in our existing store structures, and all of the really unfun work that I've got to do left. I ate my dessert before my vegetables, that's for sure.
Yeah. Anybody have any questions or thoughts on Loki's next index? I'm guessing you put this in. Oh, go ahead.
I was going to say, I'm waiting for someone to ask, when are you going to stop adding indexes?
So for sort of for like in the similar time period, but the 2.5 release actually has no dependency on Cortex anymore. We've forked the remaining software that was shared. So we used within Cortex primarily the chunks store, which Cortex deprecated use of probably, I don't know, a year ago or so when they moved to the TSTB blocks. So we were vendoring Cortex and using this chunks code that Cortex doesn't use anymore, and we're found ourselves at a point where the optimizations that we wanted to make wouldn't have made sense to merge into that project, so we forked it. We then went through and forked basically everything else, largely for self-serving reasons, because we vendor internally when we make, so we have the enterprise version of Loki that bolts on some other features and of our other projects, and the vendoring of those was a nightmare. So basically it was, you know, Loki depending on Cortex, Grafana Enterprise, metrics depending on Cortex, those both depending on this proprietary code. And it became so difficult to keep those things updated that the kind of few packages that were still overlapped, like the query front end and the ruler, we've forked them into Loki. So we may look to see if we can break them back out into a shared package with Mimir, or we might just keep them. There's not a huge amount of code at this point that was shared. So
A lot of these.
so as it stands today, Loki 2.5 has no dependencies on Cortex anymore.
I was going to say, that being said, the libraries for like distributed communication and stuff are shared between Loki and Mimir, and those continue to be updated for the benefit of both.
Yes, if you want to build a distributed system and use a hash ring to solve all your problems like we've done, there's the Grafana DS kit repo, which is where the code for that stuff lives. It actually has some other useful stuff like the runtime overrides that we use for reloading configs at runtime, and the services model that Loki uses for essentially bootstrapping components internally with services. All that stuff went into a shared library that we use with all of our projects. And as long as we don't make them depend on each other, it works out all right. But Go vendoring is not my favorite thing in the world.
Amen. All right. Unless there are no more questions, I think we're going to talk about Helm Charts now. Okay, Alex.
Hello, can you guys hear me?
Yeah.
First time caller, long time lurker. Glad to be part of the call. I just wanted to ask, I posted a question on the Slack Loki dev channel maybe about a month ago. In our environment, we're trying to deal with some MTLS challenges, and there was one little kind of strange issue that we found when we were trying to secure the query to the query front end communication. And we tried to make some kind of a quick patch, and I pushed it up to the repo, or up to my own repo, and I put it into the issue, but I'm just not sure if there's some suggestions anyone can offer for how we might go about fixing this. Is this a DS kit problem? I guess with Cortex being completely forked, I don't know if we could contribute something to the Loki repo now. Not sure if anyone is familiar with the issue. It's number 5592.
I do know that there are problems trying to do MTLS between all of the components, and it's all largely possible, but the configs weren't exposed everywhere, and maybe that's what you ran into as well. So, I mean, it sounds like we just probably need to get your PR merged, or get a PR with your changes merged if it's not already in a PR.
Because the interesting thing is that it does work for most of the services. It seems like, and I was looking into this like a month or two ago, so I'm kind of forgetting the details, but I think there was one communication that was going through this DSKit library, and that library ended up doing this kind of forces the DNS lookup of the host name and then connects with the IP address. So when we were trying to do this with MTLS with certs, then everything was failing. But everything else seems to go through just the regular gRPC libraries. Like, I'm not a Golang expert, so bear with me. I did my best.
Hey, I've actually got a question. I did. It sounded familiar. I pulled it up. I guess it turns out I commented on that issue.
Hey, Owen, I see.
Yeah. And are you running without a query scheduler?
Yeah, this is just a relatively simple case that we're trying to get up and running.
Are you running in Kubernetes?
For this one, no.
Okay. in Kubernetes, we use something in option on the services themselves, which allow you to basically publish addresses that are not considered ready yet. And so there's chicken and egg problem between wherever the queues are hosted. In your case, this would be the query front end and the queryers, which are responsible for dequeuing work from the queues and executing the queries. Where the front ends or the schedulers, but in your case, the front ends won't mark themselves as ready until they have a query connected to process any queries. And this can be a problem in like native Kubernetes where the service won't register endpoints for pods which are not ready yet, so that we have to add an extra option to register them. What I would next try from the debugging standpoint would be, have you ensured that the DNS entries exist for the front ends in whatever way you're running them?
Yeah, I mean, this is all kind of basically bare metal setup. So the host names are valid. It just seems that it gets resolved to the IP address, and it's in this. So I'm trying to remember where this was.
So the code that you referenced in this issue is forked now, so it probably would be fairly easy for us to add the config. I'm just looking, like, it looks like you're disabling the DNS lookup to. So I mean, I guess I'd need to understand a little bit more about what actually caused that, but I don't know. It seems like we ought to be able to do this.
Yeah. The patch is obviously not. Yeah, sorry, go ahead.
Oh, yeah, I was just also trying to make sure I understand the problem that the certs have the DNS name in them, but the DNS is getting resolved to the IP, and so that's why it's breaking.
Yeah, exactly.
Okay. And the fix is something to the DNS watcher that might be able to fix this.
Yeah, because I think like our environment, like at least for this setup that we're trying to get working, it's relatively static. So I just from looking at the code, like this DNS watcher, it's kind of assuming a pretty dynamic environment where this could change and the IPs get resolved. But in our case, we just want to get like a relatively simple, couple of machines.
Yeah,
that
but
would
you don't want to put the IPs in the certs because those do change frequently enough.
Yeah, exactly. Yeah, so we're able to make this work around. Like, we can do the TLS insecure skip verify to true, and then everything works, but it's connecting with the IP address.
Gotcha.
Yeah, that's kind of an interesting problem because right. I think this is what Owen you were saying, because we use the DNS entry to resolve a pool of front ends, and then you would make individual connections to each of the front ends, which is why it does it by IP and not DNS, because the DNS would resolve. So that, yeah, like if you wanted to run more than one front end worker, then I don't think you can do this way, or we'd need another way to do that. Interesting.
I'm also surprised why we don't see this in other components that connect to the IPs themselves.
Well, yeah, not a lot of folks that I know have. I mean, it's to do MTLS between all of the components.
Yeah. Well, like the ingesters, right? Distributor to ingester would be one. Or query to ingester.
Yeah, I wonder. Yeah.
Does those code paths work?
I mean, another solution to this could be a way to configure some override host name, right? Because when you're doing the TLS connection, you can override the host name that you're expecting, right? And then you could just have some contrived host name in the actual certs if there was a way to configure this to pass it through. But yeah, I mean, our problem, we don't run into this because we don't do mutual TLS. So it doesn't matter that we're connected to the IPs, right? Because there's no certs to check the host name against.
Yeah, but if we have MTLS working distributor to ingester or query to ingester, right? I'm curious why it's not working here, right? I think it's the same problem. So just be right. Like if we can just copy. If I'm guessing there's a difference there, then we don't need to solve it in a different way, right? It should just work.
Yeah.
As far as I can tell, from what I think the connection is different. So it's just from the query front end to the query, from the queries to the query front end that it goes through, I believe, this DSKit library. Whereas I think some of the other connections, they seem to be just using the straight gRPC connection as far as I can tell. And I think that code path is where this IP gets resolved as far as I could.
That would that would be consistent with what we were talking about, right? Like the other two work, and this one has a slightly difference in code path. That's probably where we should look.
Yeah, I don't know how you solve this. Either you need to have IP addresses in your cert, or we would need to have a separate DNS entry for each front end. The query front ends, the query workers will need a way to individually address every front end, because they effectively individually connect to every front end. So if you have one front end, which is probably what you have, then this is simpler, but we usually run multiple front ends. And to make the MTLS happy, the certificate will either have to contain the IP address of what you're connecting to or a DNS entry of what you're connecting to, which means a separate DNS for every front end or the IP. So yeah, there's not an easy way that I can think of to.
I think the easiest way is if you configured the host name that it was expecting in the client, right? Because I'm pretty sure you can do that when you make an TLS connection. You can sort of specify the host name override or whatever. That would be like a config change, and we'd have to pass that all the way down. And I don't know if it's worth it, like, to support this case, but I think that would be the simple solution here. Because you're right, anything where you actually want to get the addresses and the certs and everything, all that to line up and match is gonna change your topography.
Is there a difference between this connection and how the distributors would need to address specific ingesters, though? I believe we have people running MTLS there. And this is the same old one. It kind of rings familiar to the ingester client MTLS from like a year ago.
Yeah, I mean, the distributors are going to go to the ring, pull back all the IPs, and make a connection on IPs. So for MTLS to work there, you still have to have a cert that I don't know if you can create. I don't know. It is not something like, can you create an MTLS cert that accepts IPs and ranges of IPs? I don't, or to say, I don't know. That's the question. For someone to make that work, they'd have the same problem, though. You're right.
I mean, if you were using some sort of, like, if it was in Kubernetes or something like that, you could dynamically create the MTLS cert on like pod boot time, right? And then you would know the IP. As long as you had like the CA and a
let me ask this question, which is, we're just kind of, because there wasn't much else on the agenda, just exploring this because it's interesting. But if anybody has anything else, or maybe we should touch in on we're probably going to have to pull this one offline and figure out what we can do with it. But it's a great question, Alex. I don't, MTLS is really annoying. I mean, it's tough because Loki has numerous interconnections between components. So yeah, it's a bunch of work. So that's, do you have it working between distributors and?
I mean, I believe it's working. I hope so. Otherwise, but yeah, I'm pretty sure it's working. I'm sorry, I didn't. I'll try to confirm my understanding because it was a month or two ago.
That was the one spot that I remembered correctly, was because you have the ingester client, and I don't remember if we exposed there's an ingester client config that you needed to expose the place to add a cert to, and my recollection was that we hadn't passed that config through. So that was one place you couldn't get MTLS. That may have changed. Somebody may have, it was a change to just expose the config, but so someone may have done that and I didn't notice it. But yeah, I mean, it is on our list. Like, lots of people, for good reason, want to have TLS and mutual TLS between components. I can't say that it's anywhere on the short part of that list, so it's nice that folks are helping us move that forward.
Yep.
But
We can
we'll
take
take a
this
note here
offline.
to see,
Yeah.
see what
I'm
we
happy
can
to
do.
help.
Appreciate
as
it
much as I
though.
can.
Thanks for joining and asking. Appreciate it. All right.
Yeah.
It's time for our monthly Helm installment. This time brought to you by Trevor.
Always. This is real short. Vlad wanted me to mention some OpenShift support that he recently added to the Helm chart. So if you're deploying via Helm and OpenShift, you can now specify the right pod security policies and get the right service accounts through that you need for it to actually work. And just in general, there, the Helm charts have always been sort of a second-class citizen, if you will, because we don't use them ourselves, but there's a lot of activity going on there. There's a new enterprise logs, simple scalable, and there's improvements happening to the other ones. So if you do use Helm, take a look at them because they're getting in better shape than they have been. And if you don't use Helm, I don't blame you.
All right. Does anyone have any other questions or points to discuss today? Now's the time, you get to yell at us about how Loki isn't working.
We could start as a conversation. We could graduate to yelling, but is Loki working great for everybody? Is that I'm gonna assume the opposite then.
Yeah, there we go. I like that.
Excited about 2.5. It's been a little too long.
Yeah. There's a lot of fixes in there. Maybe a couple bugs and then fixes.
Did the change
the
log,
same
and it was
cycle.
hard for me because we introduced bugs and then fixed them between the releases. So I had to kind of narrow those down. But no, the improvements. There are some fixes there are some bugs in the querying around duplicates. Hold on a second.
Yeah. Are we gonna backport that? I actually need to finish that.
Well, there's fixes that go out, and actually, there's probably going to be there's another fix that Cyril did today that we got to vet a little bit more. That one mostly will only happen to folks that have high amounts of duplicate timestamps for the same stream. So deduplicating stuff is already kind of its own effort, or it's if you have a replication factor on and you have a lot of entries that have the same timestamp in the same stream, so Loki will accept entries with the same timestamp for the same stream as long as the values are different. And there were some issues where we weren't properly deduplicating all of that. So that's exists still in 2.5. That'll be out in a 2.5.1 in not too long, but there were some other issues around. Somebody discovered along the way that if you take a query, we gotta write this into our canaries, but if you do the sum of a rate of, say, namespace equals foo, and then divide that by the sum of the rate of namespace equals foo, you would expect the result to be 1. And it turns out in some cases it wasn't. So we fixed a lot of the bugs related to that. So if you write those kind of queries a lot and you were confused at why the value wasn't 1, you should upgrade and it should get better.
Yeah, and just in general, should be faster as well.
The binary operations is a huge improvement. Like if you do any multiplications by even a static factor like ×8 or divide by whatever or multiply queries together, that's all way faster now.
Yeah. To all aspiring programmers out there, this is a trick that Cyril taught me. You make sure to include a bug so that when you fix it later, you look very good.
Especially if that bug causes a slow performance. Just maybe don't parallelize all of the stuff the first pass, then you can do it later. And we can write blog posts that say like 10,000x improvement. Oh, look at the sad face in there.
Yeah, I'm trying to remember. We tested this somewhere. I didn't include numbers, I don't think.
But I don't know, lots of fun and performance improvements.
Yeah.
The regex stuff that Brian Borum has been playing around with is pretty neat. Like
Yeah.
Go's regex parser is sort of not known to be super fast. It was known to be sort of, I guess, consistent and reliable or whatever. But we found, or should I say, Brian, I can't take any credit for this. And in that link somewhere, I think he even had a FOSDEM talk about it. You can go learn more. But things that we could do with regex that, you know, we don't need to worry about with Loki, the optimizations that we can make.
I think didn't that get accepted into the Ghost standard library?
I know he opened PRs, yeah. I
It
don't
might
know.
be in
That
like
takes a while, so that's the only reason we have it for, because it just takes a while to
Yeah.
upstream stuff. But
the binary operations are on our test are about 10 times faster, by the way. So
There you go.
if you're using those, you know, A over B, and now's your chance. Okay. Any last words from folks? Otherwise, I'm gonna go pretend to work for the rest of the day.
I'm gonna make the 2.5 release happen in 1 hour and a half from now.
Nice. Is it best practices updated? Let's see. Static labels are good. Is there a subsection of this that you particularly care about? I think all of them are updated.
Oh no, well, I started writing this blog post. I have the Ed Welch's Concise Guide to Labels V3, which is a lot of what the contents from that came from. And I want to give some more. So like after the, you know, our operating practices and what we've seen, and I can give some better guidance on labels, which is what it looks like that best practices digs into a lot. But the general advice is still probably the same. You know, use the labels that you need. Try not to use more. What I think has been interesting, I've been trying to figure out how to put it into words a little bit, is actually a lot of folks have listened really well. And when we added the way to do removing the out of order constraint, like we've seen things go the other direction where there's too much data in a single stream. Loki's horizontal sharding mechanism is the stream. So if you put all of your data in one stream, we can't split it more than one machine. So labels are the tool that let you, you know, tune that. So if you have too many, you have too many combinations of labels and values. You have too many tiny streams, and that gets inefficient. And if you really have too few, which most people don't, but it does happen, then you can't shard those for scale either. So, but generally just the labels that always work the best are like apps, environments, you know, cluster name, things that you would use for querying, things you would think about how you go find your logs. But some of that best practices predates, I think, the Loki 2.0 release, which had logql v2. So now like you can extract any content from the log line. So there's really no reason you need to embed anything in the labels to do aggregations on. I think that talks about how like if you wanted to filter on log level or do sums or counts on log level, it needed to be a label. That's not true anymore. Nothing really needs to be a label because anything can be extracted.
The way that I think about this is, unless you have like start off and try to have cardinality 1-to-1 with the number of files that you're watching. Right, like one stream should generally be one file. There are cases where that breaks down, but that'll get you very, very far. You can probably run, you know, 100 node Loki cluster with that, and you'll be totally fine.
The advice that I think it helps people the most is our experiences show that if you can keep the number of unique streams in a 24-hour period, because that's what our index bucket is, so that becomes kind of relevant, at less than 200,000, you're not going to have any trouble. So, and that would be per tenant too. So you can actually have multiple tenants with 200,000 labels a day. And it's fine. So like our internal ops cluster is, I don't know, 100 megs a second typically. So it's like 8 to 10 terabytes a day, and we're pretty aggressive with labeling because like all the pods get a label, and we'll roll tens of thousands of pods in a day sometimes. So you see 100,000 streams in a day to 200,000 streams a day, and that's fine. If you start getting a lot more than that, like more than 500,000 streams in a day, the index gets big because you have to store all the labels and values in there, which isn't great. And the query performance degrades in a kind of an interesting way, which is over the course of the 24-hour period, the range scans on the NoSQL table start taking longer. So that is a kind of a rule of thumb of like, keep it under 200,000 streams a day. So, and in terms of active streams, it's a little bit more driven on memory. We have some ingesters that will have 20,000 to 50,000 active streams on them. It's if the limit, what do we run, 100,000, something like that. So I don't know. This isn't the best advice on the fly, but if you are over optimizing to get down to like 10 or 20, like you have way more room, you have way more overhead, right? Like if you're trying to get under 100 streams or things like that, you do have a lot more overhead than that. Because I think I might have
all the early
to push people in
all the early messaging around this was to prevent people from extracting request ID.
Yes.
And using that as a label.
Yeah.
Right?
So I mean, if like pod is a good example, right? Like, don't be afraid to use a pod label, even if you have thousands of pods or tens of thousands of pods, or you rotate them thousands of times. Well, thousands of times is a lot, but in a Kubernetes cluster, the pod is pretty ephemeral for a lot of times, and that's fine. But I want to try to get this kind of documented a bit better, but I would say that's probably what I would say. If you and I think in our experience, most people don't have that many streams. Like, it'd be hard to come up with 100,000 streams in a day unless you have thousands of pods that you're rolling, right? Like, because if you stick to that idea, like Owen said, which is, the file that it comes from being a stream, then you have to have a lot in your environment to get higher than that. Hope that helps, Andre. Thanks for the questions.
Yeah.
Thanks for joining, everybody. I like seeing more people join. We're still really bad about advertising this call. You found us.
Yeah. No, thanks for putting it out and sharing all the great progress. It's always a joy to see a new version and see all the fixes that are coming, especially the out of order. That was great. And excited about this indexing improvement. So thank you so much for putting that out.
Yeah, we're happy that you're using it. We're having a lot of fun building it. So
yeah, exactly.
Loki team is like 15 people now or something like that, 16, 17 people. So y'all are continuing to drive our success, and we get more people and resources, and we get to make more stuff, and it's awesome.
Yeah, we do need to start another, what do people want from Loki in 20 whatever year.
I know.
That was a lot of fun when we did that.
Forgot about that. I actually started that blog post too. There's a theme here about me talking about stuff that doesn't necessarily translate to me doing stuff, but I try my best.
I think we relate to many of the comments. Like in the past, we have been around this login environment, handling this kind of request, probably similar experiences. So it's good that all of those experiences are put together into one product. So.
Yeah, awesome. Glad to hear it.
Thanks.
All right, should we call it, Owen?
Yeah, I think so. Thanks for coming, everyone. Really appreciate it, and hopefully we'll see y'all next month. Take care.
Thanks, everybody. Bye-bye.
Okay, bye.